Another 4 student. Another 4 who still did not write up your name in the Padlet. Please. Another 3. Please enable your webcam. If not, if like I find out, basically I don't want to double check who's the one, but if you did not open your webcam, then I need to double check one by one. Your names, Fauzan Akil. Two, 4, 6. Another one. Okay, 9. Okay, now what I want you to do, you need to turn on your microphone, and I'm going to play the UTM keunggulan terbilang, and you need to sing along. So for those who did not sing, you need to sing, let's say a single. This is group singer, I think so. Misha, why your cam is turned off? Misha Shafika. Misha Shafika, Fauzan Akil. Okay, I play, okay? Then I will see whether you sing or not. Okay, good luck. Eh, wait, Fauzan Akil, your mic is mute. Alia Damia, your mic is mute. Turn on your microphone. Nisha Shafika, your mic is mute. Shafika, on your microphone. Where's another one student? I cannot see. Who's another one? Another one student. If you did not turn on your microphone after I recheck back the video, then we sing solo version. Okay, so we have got 8 students now. If I find out another person who not turn on the cam to sing now, then person will alone for solo version. Hey, another one also already closed the microphone. It's okay, I will find out after I finish this class. So this is recorded. We're going to restart.
Sama kita menunggu keunggulan berulang. Kita usaha UTM puncak letaknya membaca ilmuwan tujuan beriman bersama takwa.
I tak dengar pun suara. I dengar YouTube je. Macam mana ni? Selagi kita orang tak puas hati, you kena sing dulu, okay ni?
Bersama kita menuju terbilang jaya kita usaha UTM puncak letaknya membaca ilmuwan kawan beriman dan bersama takwa. Mari kita kami anak pun sehari kita mulia sadar ilmu perjuangan pada iman neraca perdagangan pengajaran pendidikan penulisan bimbingan dan kepada watan ini kami beri setia pada janji di ISS berbangsa KECIL dengan bangsa.
Okay lah, but why Al-Farabi did not turn on your microphone? This is session 3. Okay, thank you. Everyone is enjoy or not? So I hope that later on, if let's say like you did not fill in something, or maybe did not do any job on time, so everyone will sing UTM song. Okay, this is the first group, so we accept whether you can sing it okay or not. But in time, all of you as a UTM student need to sing correctly the UTM keunggulan terbilang. Okay, so please enable your webcam for all students. And we're going to start our class. So siapa yang dalam ni tadi? Said Abdullah. This is section 3. So section 6 is 11 AM today. please join us after this, okay? Uh, okay, enable your webcam for all students. I'm going to share my screen, and whenever I like stop suddenly, I'm going to see who did not enable the webcam. I'm going to ask a question. Okay, we're going to start our like very first class, especially in digital logic. Um, I will like suddenly stop because basically I cannot see your face when I have full screen like this. But whenever I stop, when I check that you did not enable your webcam, I'm going to call your name and then I'm going to ask any kind of question related to what we had learned. Okay. So if you have any question, whenever I like share about something, then you can just interrupt me using your voice, not on the comment side. So you need to like direct ask me and then stop me. No need for you to like raise your hand and then comment. So it easy for me because I don't want to uh, full screen and then go back to the Google Meet and then I need to open back my full screen and so on. Okay, in digital logic, if you ask me about your previous senior, mostly more than 10 students basically can get A plus. Same goes to A and A minus. A lot of students can get A plus. If let's say your focus, I guess so because it quite easy. I can see every semester most of the student can score well. So what you're going to look into in the module 1 is basically the very basic on digital logic. Maybe you are not assuming that you're going to learn electronic things, especially when you are enter the computing school of computing, but throughout digital logic is one of the very basic thing that you need to have to build a computer. So you need to know on digital logic. Okay, in our module 1, we're going to look into digital and analog quantities. You need to know the differentiation between digital and analog. And then you're going to see also how the waveform look like. And then this is the I guess interested because maybe if you don't have any background learning any digital logic class, or maybe you did not learn on the gates, so this is the first time we're going to look into gates. And then you're going to look into the overview of logic function, fixed functions, IC, and programmable logic devices. Okay, I provide you with the slide notes already, and inside your textbook, whoever want to buy the textbook or the module, it's going to be slightly different. So there is more information related to like maybe PLD. So there is something that didn't have in our class slide. So it's good for you to have that because sometimes your question will be coming out from books. As I mentioned, all our test and also final exam, it will be grabbed directly from textbook and also our slide. Like example, for example, all this in the slide you need to do, and same goes to whatever inside your book. So mostly we didn't tag from other resources, outside resources, but you might also refer to other resources just to increase your understanding and then your knowledge. So first of all, we're going to look into digital and analog. uh, I am Ran. I am Ran.
Yeah, yeah.
Uh, can you like give your overview and also what is your understanding the differentiation between analog and digital?
Mm, uh, Analog is manual and digital is more sensitive like that.
Why you did not turn on your webcam?
Oh, was testing the webcam.
Okay, please enable your webcam. Okay, if let's say you didn't.
Okay.
Okay, good. Now we continue. So based on I am Ren. Is it Ren? Ren?
It's
Uh,
Imran.
Imran.
Ah,
Okay. Based on Imran ideas and his opinion, he said analog is much more. No, district is much more strict, isn't it? Automatic.
digital is can be automatic and sensitive and accurate.
Okay, analog is flexible.
Analog is it's not flexible, but what is it's the opposite of flexible.
Oh, okay. Let's see what is basically the meaning of digital and analog. Okay, first of all, we're going to look into analog. Um, okay, basically, analog is a natural quantities. So it is continuous. Let's say I give you an example. If you have some data that have like the value of 1, 2, 3, we can call it as a digit, digital or digit, because this one is more discrete. But continuous might be 1.01, and uh, it is not digit basically, and it going to be after this you're going to look into analog digital. And for the analog, you can see the example here. It will be continuous. It will be continuous, and the value is everywhere. If let's say for digit, you're going to have your data at once, 1 a.m., 2 a.m., 3 a.m. So there is no data in between of them. But for analog, you can see that you have the data value in every second, every minute. So let's say you're going to do as experiment, then people will ask you at 1:30 what is the value of your of the temperature, then you can set it. But for digital, you're going to see that if someone asks you what the value of temperature at 1:30 a.m., you don't know basically, and then maybe you might confuse because it is discrete and you only have digital value which is discontinuous. So we'll go back to the analog. So this is basically the huge differentiation on continuous, and for digital is discontinuous or discrete. So you're going to see what is analog now. And I hope that you understand the first very basic differentiation between analog and digital. It is continuous and discontinuous. And basically, analog system can generally handle higher power. Okay, the example of power. Normally, for your battery, power bank, they basically have digital system, and analog system, if related to power, it's basically can be referred to your house electricity, because the power is more than like 240 watt and above, so it's much more higher. That's why our house cannot use digital system. So it's not support for digital system. So you can see there is 2 point now that you can differentiate between analog and digital. So this question might be also asked in your part A. So for your part A, it's going to be like multiple choice. Maybe they will ask, what is the differentiation between analog and digital? Now you know basically there is two big differentiation. First, continuous and discontinuous, and another one is analog can handle higher power rather than digital system. So this is the example on how you apply your mathematical equation into the analog system. And now is the digital quantity, which is discontinuous. And basically, digital system can process, store, and transmit data more efficiently, because it just transmit certain value at certain time only. So for analog, it's hard for you to transfer and transmit all this data. It's more complicated, maybe because there is a lot of value in time. You can see a lot of value in every second. And for this read, you can transmit easily because you have several value only. So that is basically about analog and digital. So this is another differentiation that you might also know related to analog and digital. Analog is used best 10. Okay, you can see a representation of 10 different level for this analog. Okay, so analog system, a combinations of a device that manipulate value represented analog form, while digital normally, as I mentioned, although you can see over here, you have the value at every time. You can see over here you have the value at 1, 2, 3, and so on. And previously we can see at the analog one, you have the value at each point. So as I mentioned, for digital, you have the value at certain nombor bulat, isn't it? For the time and that. But for analog, you have, let's say, 1:30 a.m., 2:30 a.m., 2:15. So all the value is there. Instead of that, digital also normally the system are using binary term. So binary term is represent on 0 and 1 or low and high. Another one you can also use as on and off. This is the value of the system, not at what time the data is. Okay, so like this is the value at 0.5, let's say 1.2, but the value over here is digit 0, 1, 2, 3 until 9, and you can have a lot until infinity, but in time it continues. That is the meaning of this. The level, okay, the meaning of the level. But for the level, for binary digital, you use binary only, which is 0 and 1. So normally this is the digital value. You can have like different kind of value, but this is the mostly system used for digital, whether it is turn on or indeed it is turn off. And for digital system, a combinations of device that manipulate value represent a digital form. So you're going to see over here certain time it's going to be 0, certain time it's going to be level 1, and etc. So this is on or high, this is low or off. So mostly, let's say me myself familiar to use low and high, but maybe some other lecturers familiar to use 0 and 1, but maybe there is a lecturer also are familiar with on and off. So you might need to know all of the term that represent digital, because the one who did question is not only one lecturer. So yeah, you know, if let's say there is a lot of person do something that we combine together, you might confuse, but as long as you understand it, then it's easy for you to answer the question. Okay. This is another example. You can see over here you have the analog version, which is continuous, but on top of your analog, you can also do a sampling, which is you convert it from analog to digital. So you're going to like taking a sample only at a certain time for the data. Then you're going to have like from this is original, and then doing this sampling, you're going to do the process of digital analysis of signal and digital assignment of signal until another last step is digital representation of signal. Previously, I don't think that there is a question asking you step by step, but on top of analog and digital, normally maybe you going to be asked what is the type of method to convert from analog to digital, and just on your understanding. So no need for you to like memorize all the method step by step. As long as you know, okay, this is the picture to do the analog to digital and to do the sampling. Okay, this is another one. Example basically is quite similar to this. You can just like refer because this is like extra knowledge for you. Okay, now it's time for me to ask. Everyone are turning on the webcam. Unfortunately. Um, Afwa Alpha. Okay, can you point up to me maybe where is analog system inside this picture? Which one is analog? Ada ke tak ni? Yes. I tanya seorang je. I ask for Alpha. So what I need to call you? Analog. Which one?
Uh, the analog is A, the watch, and C, the television, the old television, and E, the telephone.
Okay, good. So that is a correct answer. Thank you.
You're welcome.
So I will continue back. Okay, this is basically analog system. This is basically analog system, and this is analog system. You can see this is analog watch, of course. Every single point over here, every second, then you can see it's continuous. But if you compare to this clock, this one is digital clock, digital watch, and this is your smartphone, and this is digital. If you compare to older and traditional telephone, you need to dial like drag it over here. I guess so. I forgot already. And then you can call. So this is continuous versions of telephone, which is analog. And the differentiation between all versions of televisions is analog and this is digital. And currently also our signal for television, I guess, starting last year, right? They are moving to digital fully. I don't know whether it's already fully digital or not because I guess I never watch television nowadays. Maybe 2 or 3 years already I didn't watch television. So my kids only watch TV and they are just watch YouTube. So I don't know whatever information is about our new technology for the televisions. So that is for analog. Thank you, Afwa, for answer. Okay. So the digital, as mentioned, also this is digital. Okay, this is example of digital, and this is all the example for analog system. For digital, okay, digital technology is relatively new compared to the analog technology, which is traditional way and all versions of devices. Analog system has been changed to digital system. So what is the example like computer, manufacturing system, medical science, transportation, and many others more. Okay, this is example of digital. And in our subject also, our main title is digital logic. So we're going to look more on digital rather than analog. Why we need to know about analog? We just want to see the comparison and how the analog system previously can be compared to digital. Okay, why you need to move from analog to digital? So there is several advantages in our life in worldwide, I guess so. There will be a pros and cons, but on top of it, if you are moving toward from analog to digital, there is advantages, which is why we move to digital. Of ease of design, easy for you to have and do the storage. Accuracy and precisions are easy to maintain. Programmable operation, less affected by noise, and lastly, ease of fabrication on IC chips. So if you have this kind of list, you need to memorize it all, because maybe in like a question for your test, it's going to be like ask you what is the advantages, and you need to pick which is the correct and normally it's going to be like multiple answer. So if you understand and memorize it all, it's easy for you to answer the question. The digital system is more efficient and reliable for to use in the data processing, to be used in the data transmission, and lastly for the data storing. So this is basically a system can be used for digital system and processing. As I mentioned, also every single things in the world, as including ourselves, we have the positive side, we have negative side. Same goes to things in the world. It's going to be have disadvantage and advantages. Maybe in your versions, in your versions, your like years, ages, maybe you look more onto technology of smartphone. So maybe you can see the comparison between iOS, Apple phone, and Android phone. Maybe if you want to buy a phone, you're going to like compare what is the advantages and the disadvantages. There is no one thing, not just one thing in the world have all advantages, unless we compare things with price. Maybe you like, okay, I will buy this smartphone because it's much more expensive, and my friend will know that, okay, I can buy expensive things, maybe something like that. But throughout, I guess all of us will do a comparison, what is the good and what is the advantages. For digital system, there is disadvantages, which is, although it's good, there is a lot of benefits towards digital system. But for the advantages, it have greater bandwidth, and then it might be a cure in sampling error, because when you want to convert from analog to digital, sometimes it's going to be error, and there is some value, maybe several portions is not converted directly or fully. And then compatibility with existing analog system, maybe you have um, digital television. Let's say you want to connect to the area. I don't know basically about area, but if your system that you want to connect together have analog system, so it's also hard. You need to check the compatibility. So this is the some of listed why digital have disadvantages. And another one more thing, short product half life. If you compare with like old version of television, the big one, the big television version, you're going to see that sometime your mom, your dad, or maybe your grandparents still have this kind of television and still can be used because they have long life value if you compare to our digital products nowadays. Sometimes you've been given the warranty, let's say 1 year, 2 years, and then suddenly 2 years it start like broken, or maybe there is something wrong to your television. It's not long in life. Okay, that is the advantages and disadvantages on digital. And this is an example for you to see analog and digital system. Many systems use a mix analog and digital electronic. So as I mentioned, if let's say you check the compatibility, they can join in together, digital and analog. Then you can mix them together to take the advantages of our existing technology. Typically, your CD player accept digital data from CD drive and convert it into analog signal. So this or CD or maybe your DVD, when you put it into your system, this one is your player, and then you will hear the sound, and the sound is in term of analog signal, isn't it? I guess you already learned it on your physics subject. So you can see that from digital it convert to your analog, so it is mixed in system. And you're going to see also you have all the converter inside the whole system, from your player to get the music or to get the voice. So this is the converter. Previously, in previous slide, you see the analog to digital converter, right? But now you see the digital to analog converter. So you're going to see that you have a possibility to have DAC, and then you can also have the CAD. What is the term? Is digital to analog converter, or another one, analog to digital converter. Either one, you need to see where you apply the system and what kind of system that you want to have. So over here you have CD player. You put into your player, and then you have CD drive, and then you put into player, and inside your player there will be have the DAC, digital to analog converter, and it will change to something very nice, which is music, sounds, and everything about your analog signal of waves. You can see over here, first of all, you're going to do the convert digital sound from your CD to analog. Second, process amplify the analog information, and third is convert the analog signal to sound. So this is example of hybrid system. What is the meaning of hybrid? Last time, although I already do my master, I don't know what is basically hybrid means. So hybrid, you can Google what is the meaning of hybrid, but when you have at least two, you combine at least two system, it called hybrid. So you can see over here you have analog and digital system together, so it called hybrid. So you have the hybrid system for your CD player, from CD drive to the voice or music, it called a hybrid system. So you can just read over here to get more understand how basically from CD convert to the voice. So this is several converter that you might use. As I mentioned, you might have ADC, you might also have DAC. Analog to digital converter is ADC. You convert analog signal to digital signal using a process which is called as sampling, quantitation process, and digital conversion. And along that way, you're going to have also some error. It might occur in your process. This is the list of the disadvantages for a converter. So digital to analog converter, the AC needed if speaker is using analog system, and you need to convert digital data to analog signal in order for the speaker works properly and the sound can hear by human ears. So you need to know these two type of converter. And I guess this is all like quite bored because you need to know something that maybe not useful for yourself. You just like apply existing technology into your current lifestyle. You said, okay, this is the new technology, so you just use and grab the digital without having needs for you to compare with the analog system, right? But throughout all of this is like theory basic about something. Same goes to your if you want to know something and if you want to know about a person, maybe if you are interested with her or him, so you might know the background of the person. Same goes to the system also. So let's take a look into next subtopic, which is on digit, logic level, and digital waveform. Before we move, is there any question? Can we directly move? Okay, Lu Ziyuan, you can
Doctor, I want to ask, is smartphone consider hybrid system or just digital?
as mentioned, as I like doing a research, it called as digital. Although you can see that you have the converter inside that, which is from uh, digital to analog, right? Because you need to hear, but I choose it to be digital. In terms of system, of course, it can be called as hybrid system because you have two technology inside, which is the digital system and analog system. But that combination system is just like a call for dual system, but to like categorize them, it's going to be digital.
Okay, thank you, Doctor.
Because you have only two things, which is analog and digital, in category. Hybrid system is like not to compare, but it is like combination of them. If you need to like categorize them, it's going to be digital. Okay, is there any other question? I'm sharing my screen, right? Okay, so let's we move to another sub topic, which is digit logic level and digital waveform. Until here, I was like also feel bored when I want to learn something about history, because I had history subject. But later on, I really love, especially when I deal with gates, and then I need to like do the circuit. But unfortunately, your section still cannot do it physically. That's why it's quite sad, I guess. So because I love to do, to make my hand dirty with the things. If compare nowadays, you need to do all fully online, just use the software, and you cannot play with wire, you cannot play with battery, you cannot play with the real gates, and so on. Okay, but it's okay. After you come to UTM, maybe you can ask the permission to, for the technician and also lecturer. Maybe you can try to play around with the circuit and the logic gate labs. So now you can see over here, as mentioned previously, in digital, now onward, you're not going to see analog, maybe a few, but it is all fully digital. You have two levels, high and low only. So high, what as I mentioned, is going to be 1, and low is 0. And it also can be called as on and also off. Digital electronic use circuit that have two states, which is referred to this one, as I mentioned. So it is normally like this. You can also have this kind of waveform. Sorry, I guess like this. Maybe so. As long as you have two value, you can see over here, you have 0, you have 1. So it can still call as digital waveform. So when you Google about digital waveform, a lot of figure will be show up, and normally and mostly in learning, we will like use this kind of waveform, the square waveform. So in digital, there is no this value. It is invalid. Whatever in between, we're not going to see it. So you just to see it.
It's 9 hours.
Going to see only high and low only. Digital waveform change between low and high, and then a positive going pulse. Okay, this is very important, although like this is quite new, like new for you to learn about a waveform. Throughout, after this, you're going to apply this one. You're going to apply like a combination logic, or maybe after you go for a clock. There is a lot of this term will apply, which is positive pulse and negative pulse. So what is the difference between positive pulse and negative pulse? Or maybe you can call, is it positive clock, or maybe it is negative. So you need to know positive pulse is goes from low to high level. Okay, like this. When it started with low and it go to the high, if you later on, okay, don't confuse with this arrow. This arrow will be represent as clock. Later on you will learn. But when you have low and then go to high, it's called positive. It's called positive clock, or it called as a positive pulse. But Hi Abdul. He just take his vaccine yesterday. Hope that you are okay. Okay, I continue. For positive pulse, or maybe later on, not now, okay, later on you will play around with clocks and etc. So now you get to know it's called as pulse because it's a waveform. But you're going to apply this, which is if positive. If you have like error, this one is going to be a clock. You're going to see this is positive pulse or positive clock. And if let's say you have the clock version, when you have the arrow goes down, which is from high to low, it's going to call as negative pulse or negative clock. So it is not listed here about the clock because I just mentioned to you because sometimes you will mention, okay, I will like understand it later on. This one is like sentences. Okay, I will go through back. But please understand it from now about positive and negative. What is the difference? Because in question, normally they just said, okay, by using a positive clock, how your output signal will be look like. So if you don't know positive clock or positive pulse look like, you cannot answer it correctly. So sometimes it will be said, by using a negative clock, how the output look like. So it's not going to give you representing on the picture sometime, but sometime also it will be shows the representation. Otherwise, you need to know the very basic thing, positive and negative pulse. Is it okay? And another one is digital waveform are made up of series of pulse. So you're going to see like this. This one is positive. This one. Okay, let me draw the positive. This one is positive. This one is positive. And why I cannot click? Okay. Like this is negative pulse. This is negative pulse. This is negative pulse. This is what mentioned here in these sentences. It's made up from series. Means that you have positive, you have negative pulse together. Okay. But for later on, you will see why you need to know positive and negative, because if positive, you need to look over here only. If you apply negative, you need to look over here only to get the output. So later on, you will play around with the signal. If you have two input, let's say you have this input, another input. So how your output will be look like? So it's depend on your clock later on, whether how your clock look like, and also it going to see if it's positive or negative clock. No worries. In time, you're going to learn it slowly. but just to know the basic things. Over here, you can see what I mentioned previously. Also, you can see rising or leading edge from low to high, and then you're going to see also at this side falling or trailing edge. This is a positive going pulse or positive logic, and it can call also active high. So sometimes, as I mentioned, we have a lot of lecturers. Sometimes the lecturer love to use this term, which is positive ghost pulse. In your sentences, in your question, okay, what is the output? If you are using a positive ghost, positive clock, but maybe the lecturer like to use. What is the output if you use positive active high, clock, and so on. So either wise, you need to understand because both is represent similar thing, positive logic and active high. So you're going to see this one is easy for you. Bit 1 is high, bit 0 is low. And for negative, it's different in this term. Don't confuse. So for negative, it's falling leading edge over here. And this one is rising trailing edge, which is from high to low. This is negative ghost pulse, and it can be called as active low. Positive is going to be active highs, negative is active low, and the value of high and low is different. High for positive edge is 1, high for negative edge, negative signal or negative logic or active low will be 0. So it is changing in the value. So hope that you notice about this. Okay, this one also you will apply later on. This, if let's say you can see directly goes to your maybe this is your gate, not gate, or maybe this is clock. So whatever the elements over here, if there is no bubble, it's called as active high. But when you have a bubble over here, it's called as active low. So this is not only applied to your gates, but later on, you're going to have also a clock and so on. If as long as you state in your mind, if you have bubble over here, it is active low. Easy, right, to differentiate between active high and active low. Okay, so I hope that you understand between active high and active low, or positive pulse and negative pulse. And now we move to digital waveform. There is two type of square wave, which is periodic and also non-periodic or aperiodic. What is periodic is the signal keep on repeating after a period of time. So what is the meaning by repeating? You can see the waveform is similar. It is not like 1 or 2 period is similar, but maybe at the third. Okay, I give you an example. You can see over here at 1 period also is already similar. After that is repeating. It's called as periodic. But maybe you can also have like this. And then it's continue. You can see this and this are similar, and then it's going to repeat the same. It's still called as parodic. But for non-parodic, you can see there is no any correlation between each other until the rest. So it is called as a non-parodic, which is doesn't have also period, because you cannot see which period. Okay, maybe this is T1, you see, and then this is T2. There is no period for non-parodic because you cannot justify where is the continuous thing or repeating. So this is the two differentiation between digital waveform. So if you have any question, just no need for you to raise hand. You can just voice up. Okay, can disturb and interrupt me while I teach, so it's easy for us also. So this is example of periodic signal, and this is a periodic signal. You can see the signal, as I mentioned, it can be not only a square form, you can also have like a triangle, sawtooth, sine, and normally we're going to use square because it's easy for us. But this one is for digital. This one is analog, but in terms of waveform, it's called as a periodic signal. And I guess if you learn physics last time on your form 5, I guess so, you already know about this equation, which is for frequency. You have frequency is the rate which signal repeat itself at the fixed interval or tempo or t over here, or time or period. A period is time for the age of the one pulse to corresponding age of the next pulse is measured on second. I'm not going to like go too deep for like frequency and period, because this is the very basic on physics in your SPM. I guess all of you understand. I really love physics. So this one is unit of hertz for frequency and unit as a second for your period. So you need to memorize back the equations. So there is an example over here. You can like play around with the value and try to do exercise back. How you going to get the period if you have this frequency. Maybe you can just play around with yourself with the value, and then you change. If let's say you have the period, what is the frequency value? You just play with the wait I think I have meeting. I just want to play. Let me check calendar so I can record them. Okay, and now if you go to lab OSI, isn't it? Oscilloscope. Oscilloscope. This is how it's look like. You can play along with the signal. It's quite nice. Last time for myself, I have this kind of oscilloscope play with at the lab. Maybe nowadays you will see this version. For me, I look this version only the older versions because I'm the older version also. Uh, this is how square waveform look like. We can change basically the type of waveform, and this is sinus waveform. And about unit conversion, whoever love mathematics, I guess you already know. And please make sure you know all these unit. I'm not going to teach you, and we as a lecturer also not going to teach you basically and apply it into mathematic term. Okay, do exercise on this and so on. We just give you the unit conversion. You need to do by yourself, because in question we will just give you whatever unit we want. In this digital subject, we will learn on digital things, get and so on. So this is more on mathematics, your own knowledge on applying the mathematics. So you need to memorize this table. What is Tera value? Because we just directly give you, let's say, 1t. So if you don't know 1t, you cannot calculate, because in this digital logic subject you also will have the mathematical equation and calculation at the end of the subject. So we will directly give you the value. I can't remember, but I guess you can also be asked in your part A, which is multiple choice, convert convert the value from this. So what is the answer? Maybe it's going to give like 10 or maybe 100 time of 10. Just to make you confused, maybe we can like change the value in front. Maybe you have like 1 times 12, or maybe 10 times 12. So which one is the correct answer? So you need to know what is the meaning of all these unit. Okay, I hope that you remember that. Please make sure you try. So you can see over here, we can apply it into the equation for frequency, finding the frequency, calculate the frequency or the period. So you can see over here, you were given the unit. So you need to find out how you're going to convert it. Because if let's say you don't know, then it's hard for you to get the correct answer, or maybe like, oh, I need to Google what is the conversion 4K, or maybe I need to reopen back my notes. So don't do that. Instead, please make sure you get familiar with all the units and easy for you later on. So this is example, and you can do also, there is a note for you to apply the example. And this is my suggestion. You can like increase your increase your skill by changing the value. So you're just changing the value, and then what is the answer that get, check it whether it's correct or not. Maybe you can do it with your friend. You give the question to your friend, and then your friend is answer, and so on. This is mathematics totally. And in physics, the equation also you already learned. And there is also exercise. If you buy the book, in the book also there is a lot of exercise. Same goes to in the notes. Please try all the exercise, because sometimes the question is just grabbed directly from the example and also the exercise in your notes. Okay, over here you can see, I give you an example for this exercise. For E, you can see that you have 10 millisecond. Milli is 10 to the power of -3. So you need to know if -3, how it's look like. So you're going to convert it 10 to the power of minus 3. And what is the meaning of minus 3? This one is your 10 minus 3 is going to go to the left. This one, I guess, mathematics already. 1, 2, 3. You move the point from here to 3 times to your left. Then you put 0, 0. Then you will get 0.01 second. So this is how you convert. And if let's say this is frequency, what is basically, okay, let's say this is frequency, what is the, sorry, this is tempo, which is period. If you convert, what is the frequency? So you can play around with the equation. Same goes to example B, C, and D. Okay, this is the answer. Later on, maybe you can also screenshot and do it, because I do believe in your notes, it's just provide you with this empty space. So if you want to have the answer, you can screenshot and then do it by yourself later on. But I guess it is not too critical. I do believe all of you can answer it correctly. There is also another exercise. Please try to do so. You can see over here, this one is more to negative value and negative units. Nanosecond, pico, milli, micro unit. You can see over here, P is pico. Then I'm correct. And for this one is kilo, mega, giga, tera. It is more to positive. Then you need to like times positive number over here. And if positive, let's say you have the E times kilo 10 to the power of 3. What you need to do is you need to move. If let's say this one is positive, basically we did not write the positive. But if it is negative, we will put -3 like the previous solution for 1.1. So for this 1.2, it is positive, which we just left it as 3 digit. And previous question, if negative, what we're going to do, we need to move to the left, right? And for positive, we're going to move to the right. So you're going to see, I'm going to move to my right 3 times, 1, 2, 3. So I have 0, 0, 0, and point over here. So my answer is 10,000, what, million, I guess so, 1 million. So you can see over here, it is the answer. You can also have this kind of answer, and you can also have, you change back the value, and this is answer. But if let's say the question, the answer will be provided in terms of units over here, so you need to convert it into the specific unit that provide. And maybe you can play around also with the value and the equation to find the period. So this is the answer for you to tag for solution example 1.2. Please try to do all the example. Okay, now we go to the pulse definition. You can see over here, pulse is rapid, and then it's changed in the amplitude. You can see sometimes it's high, sometimes it's low, and the signal from the base value, you will see this is the starting or we can call it as the baseline, and the value too high or a low value followed by a rapid return to the best value. And then you're going to see also there is a with pulse, a measure of the durations of the pulse, and then rise time and fall time. I guess this one is very easy for you to understand, although I'm not mentioned and I'm not teach you. If rise, how it's going to look like, and if fall, how it's going to look like. So this is the time for you to see it's going rise, and then this is a time for you to can see this fall time. And there is at certain level, maybe this example point up at the 50%, so the pulse width is this. Maybe you can see also at the 10, maybe you can have the pulse width also. It's depend on the question, but basically where you can find the pulse width, where you're going to find the rise time from 10% to 90%, from 90% to 10% on the fall time, and so on. So this is just example, but mostly we not really ask all those type theory question. Maybe only like 2-3 question, including previous theory thing that you need to know. This is like still a basic thing until you reach the gate. That is the very important. Starting from that, you need to understand better. So repetitive pulse wave, you can see this one also quite similar, which is we already look into. And there will be amplitude, pulse width, and also period. Although previously you look onto the like analog wave, how you going to put the amplitude, how you going to put your pulse width, but this one is more on digital wave, which is can see this is a period, this is amplitude, and this is a pulse width. And you can see over here there is a duty cycle. What is the meaning by duty cycle? Duty cycle is a ratio of TW, or your pulse width, and then to the T is your period. Ratio of your pulse to the period. So how you going to justify your duty cycle? Your duty cycle is a fraction of time that a system is in active state operation. So you can see that this is the definitions as I mentioned previously. Ratio of TW to T, which is pulse to period. And the equation going to be look like TW of T. So this is period, this is your pulse width. So if let's say you were given with the waveform, you're going to see that this is your pulse width, and all together from here to here, it is your period. So you can see the example of question, a periodic digital waveform. Periodic means that you have the period, isn't it? Has a pulse width with 1 millisecond, which is from 1 to 11, and the unit is millisecond. And the period time is 10 millisecond. So calculate the duty cycle. So you need to memorize the equation. Duty cycle is 1 milli over to 10 millisecond times 100%. So this one is just putting the 100% over here. So you get duty cycles is size a 10%. Again, as mentioned, please play around with the value and try to test. Or maybe the easy way for you to do, ask your friend to give their value, and you can like change between each other. You do several value, your friend do several value, and then you change the exercise together. That is like much more easier. And you have that exercise. If you are the one who change, maybe you feel like lazy, or that's why I ask you to like having a friend to switch exercise together. So you can also try this exercise. This is basically quite similar to this example. It's quite easy. You just apply directly into the equation. This one, you were given the period, which is your t, 1000 millisecond, and then you also were given with the duty, or what you need to find is you need to find on the duty cycles already given, 25%, you can see. So this one is the width of your pulse, and you need to justify how you're going to find the value. So you need to play around with the equation. If let's say it's going to give directly the duty cycle, maybe you need to find the pulse. So maybe you were given with the pulse and the duty cycle. You need to find the period. So vice versa. What is the question? Someone, can you read the question for me? Why? Why any one of you didn't help me to read this question? But you asked me.
You just wrote the question just now.
Oh,
Yes.
okay. On the previous question, why did we multiply with 100? Let me go back to the specific slide. And why don't you just ask me directly? uh, this one, which is the part that you asked me, is it 100? Who is this lucky person? Al-Farabi. Oh, your microphone cannot work. We can't hear you. Maybe I think that your microphone is turned on. Maybe you need to double check your microphone later on. Okay. By multiple or times. I guess it's going to times with 100. We multiple with okay. Go back to the this question. Wait, Okay, go back to this question. First of all, we have the duty cycle equation. The duty cycle equation is TW, which is your pulse width, over your period. And this one is multiple with your 100%. 100% means 100 per 100. So this is 100%. Basically, this is just a percentage. I guess it's not affect you unless they ask you in the value. So this is basically how your equation look like. So you have pulse over here. Your pulse is 1 millisecond, and it will be over your period, which is 10 millisecond, and then times with 100%. So this is basically your duty cycle. So I hope that you understand, Farabi. I cannot hear your voice. I guess it's not too hard for you to apply. Later on, maybe you can try this exercise, the example and this exercise. If you did not understand, you can direct WhatsApp me, PM me, okay? So I just repeat again. For duty cycle, you have the equations of PW or your width pulse width, and you have the, I guess I did a wrong. Okay, maybe this look like this. It is not capital letter. Sorry, my bad. And you have the period over here and times with 100%. Maybe you like quite confused with this. So it's basically multiple with 100%. And same goes to here. This is multiple, and you have this kind of version. So you get 1 millisecond over 10 millisecond times with 100%. I don't know whether the answer is wrong. I guess it's correct. So you can also.
Kita akan mulakan. Prof, sedia?
Yeah, I have I have courses basically just I'm going to play and record. Okay, this is another exercise. Please try to do so. It's also like you can directly apply. You have duty cycle. Duty cycle is 20%. And then you're going to have like equal to duty cycle is TW over your T, capital T, times your 100%. So if you can just apply it directly, this one is your period over here, and this we can like cross it, and then you have 25 and then 100, and later on you will like finding the value of TW. TW equal to 25 times T, because you will bring this over here, right? And your 100 will be like this. This one go back over here. This one is multiple. This one is time. This one is divide. This one is a multiple. So go over here. It will be divide. Then your T is 1000 millisecond. At the end, you will get the value of your TW or your pulse width of 250 millisecond. So play around with your calculator, play around with the value, change this value, and then find the TW and so on. So this is on state over here. You can see this is your on state, which is on or high. How about your off state? So your off state of course 1000 minus your on state. So this is your off state. So this is the value. So it's quite easy for you. You know that your on state also called as the TW or your pulse width, isn't it? So this is your pulse width. So you can see over here, it's not directly ask and inform you. This is pulse width. You can see that, or it's just mentioned on state. So you need to understand on state is also referred to the pulse width. So when you get the pulse width over here, the value, play around with the equations of duty cycle equation, and you will get the value of the pulse width, and you minus and deduct the value from your period, you will get the offset value also. Okay, so play around with the value and then try. Maybe if you have difficulty, you can WhatsApp me directly. Okay, and if you still did not understand, please raise your hand and then direct open your microphone, ask me the question. So there is another example. You can see over here you have 1.4 example. It gives you similar things, the value of your period and the value of your duty cycle, and it's not directly ask you on the period width, and it's going to give you only on and offset. You need to find on and offset. This one is your TW, and then after you get this one, you will get your offset, quite similar to the previous equation. So once you get this, you will get your offset also. Is it okay? So you also have another example. Over here, you were given the duty cycle with 40%, and for the duration of the system, which is your T, which capital T, which is 500 millisecond. Calculate for pulse width. See, it's directly inform you. It's not use the on state anymore, but it is direct, so it is easy for you. You need to find the TW. Determine the offset of the system that operated with the ratio of the duty cycle. So this one also similar thing, only different in how the question represented. So sometimes it's directly asked on and off state. Sometimes it's like play around with the words and sentences just to make you confused whether you understand it or not. So you're going to see that determine, okay, determine the offset. Okay, this one you can directly get the TW. And of course, after you have TW, similar things, whatever happened in the equation exercise 1.3 and exercise 1.4, you just deduct the value. Where is it? Okay, here. You just deduct the value from your periods, deduct with your TW, you're going to get your offset. See over here, this is onset value or your TW, your pulse width. Similar things, but you can see these represent quite long compared to this one. You will see like, okay, this is much shorter in question, but this is just a representation of question. Basically all the step is similar. Instead of having this kind of value, maybe you will change also, not given the period, but you were given with the onset value maybe, and find the value of period. So you can play around like that. So maybe you will see how you can play with the equation. Okay, this is a timing diagram. What time? Another 15 minutes. A timing diagram is used to show the relationship between two or more digital waveform. This is not a single, okay? This one is a single wave. This is a single wave. This is a single wave. But when you have at least two, waveform or digital waveform, you can see over here you have 1, 2, 3 waveform over here. When you have two or more relationship, who's again? Can you just speak out? And you're going to see that all this representing as timing diagram. And you're going to see you have a clock. Normally clock represent of your timing value. Tak ada orang yang nak tolong baca Kesian kat saya ni nak keluar masuk ni. A lot of you did not turn on your webcam. Oi, Joey. Accidentally press Shi Junhoi. Okay, I want to ask you a question. Shi Junhoi, are you there?
I'm here.
Again. Are you also accidentally press your webcam?
No, I didn't
Purposely.
open my webcam actually.
What?
I don't open my webcam.
You don't?
Yes.
No, I can't hear you clearly. You don't what?
I don't open my webcam.
Why you don't open your webcam?
Because my webcam has something wrong, you know.
Oh, okay. Then can you log in into your mobile phone?
Okay.
Okay, I want to ask you a question.
So you want me open my webcam?
Yeah.
Okay, fine. Sorry, wait me a second.
Okay. Now, I want to ask you a question. Let me share you my screen.
Okay.
Okay. My question. What is the value? Mana tadi? Okay. What is the value of A, B, and C at T3? I repeat the question. What is the value of A, B, and C at capital T3?
What is capital T3?
What is capital? Okay, I draw maybe. What is the value of A, B, and C at the T3?
Uh, uh, A is 1. Uh, B is 2. C is 4.
What again? B is
2.
2.
3. C is 4.
A is
1.
okay.
Period. B is 2. C is 4.
C is 4. Okay, thank you for your answer. Let me check whether you already turned on your webcam or not.
No. I just opened, but it says can't find your camera. Check your system settings. Blah 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 blah. I don't know why, but
Okay.
I really open it.
Okay, maybe next time you can also like try to log in into your phone so that I
will.
can see.
Okay, I will.
Okay.
Thank
So
you.
now, go back to the question. Before we go to the question, basically, okay, this is the representations of a timing diagram. I repeat again, when you have between two or more digital waveform, you can see you have one waveform, two waveform, three waveform, waveform A, waveform B, and then waveform C. These all called as timing diagram when you have the clock representing here. Sometimes your clock will be down, sometimes your clock will be up. It depends on how your lecturer want to draw it, and sometimes depend on who asks you the question. So let's say over here, as we know, basically T is represent as the period, and this is the periodic waveform, or it's called as a clock, which is it will be periodic and it will be have T value, which is your period. So this is T1. Okay. So you can see over here, you're going to have T1, T2, T3, and then it's repeated until the rest, isn't it? Who asking me question at that chat? I guess later on I will. What?
I accidentally pressed the raise button.
Maybe you want to play with your Google Meet. Okay. Uh, let's we close the chat, I guess, window. Okay, this is T1, T2, T3, and so on. And you're going to see at this, like, this time is 0, which is starting, and then this is 1. You can see the value in between of all this. And how you see the value itself, as I mentioned, in our term, after like analog, after digital wave that you look, maybe you can slide back to your previous note. You only have a value of 0 and 1 for digital. Okay, so there is no casting 4, 2, 3, and so on. You're going to see the value now. At 1, you have the value of A, 1, 0, 0. At T2, period 2, you have 0, 1, 1, 0. You have at T3, you have 1, 1, 0, and so on. So, okay. So this is the value. As I mentioned, although it's not shows use at starting over here, of course, in equation is just directly give this part. They're not going to help you in terms of this kind of version. So you are the one need to do it by yourself, putting all the 1010 inside, and you just been given like this. And at certain level like T0, T1, T2, and etc., you're going to find your own value. What is the value of A? What is the value of B and C? Later on, when you know on the get, when you have all this, we call as input. We call as input after you know about the gates. Okay, you have inputs and you need to draw your output value. Normally it's called like F or maybe the output. So you need to draw how the waveform look like based on the input. So all of this is depend on what gate. Maybe you have NOT, maybe you have OR, maybe you have NAND gate. It's depend on the question. So at this stage, the early stage, you need to know the value is 1010. Although it's not mentioned over here, you need to know, okay, if let's say it is high, it's 1. If it is low, it's 0. Okay, you can see over here at time of 8, this is example only, the value of A, B, C, D is low, or it can call as off, or the value also can be as a 0. A diagram like this can be observed directly using logic analyzer. Oscilloscope also can. So you can also analyze with the logic analyzer. And this is another example at the bit of time 7 or your T7. You're going to see over here the value. Basically, it is overall. And this is the value for A is 1, for B is 1, for C is 1. All is high. And at your T3, this is all. And you have the value of A is 1, 1, 0. A and B is high, C is low. Or A and B is on, C is off. So this is how you play around with time diagram. And again, as mentioned, sometimes your clock is at below part over here, so don't confuse. Eitherwise, it's just similar, it's still a clock. And normally this A, B, C until Z is representing as the input or the output. Depending on the question, it will mention to you. Okay, instead of just giving you the timing diagram, you can also have the table. Let me check my slide. Okay, I will finish this part and then we end our class for today. Okay, you can see over here, instead of just giving you with the timing diagram, you can also been given with the table. So normally, when we play around with digital logic, when we have table, it called as true table. Not only like table, not
It's
the
10 hours.
not the timing tables, but it's called as true table. So normally you will be asked, please draw the true table for this, something like this. So maybe you were given with the true table, you need to draw the timing diagram eitherwise. Later on you will see it is not just an easy like this. You change the value and then put it into the truth table, but on top of the, when you have the gates, you need to draw the truth tables based on the gate, so it's much more complicated. So that's why you need to have the strong basic play around with the timing diagram, play around with the truth table. You can see over here at the clock 1, and you can see over here it called as a positive clockwise. As I already mentioned, this is the important point. If you have like this, okay, normally this if one is starting from 0, and then if you have like this is positive, and when you go down it's a negative. But your negative cannot be here, okay? Your negative cannot be here, which is from rise to up. You cannot be here. Although you represent it as a negative clock, you cannot have your negative here, but you can do this. So you cannot do like this. Over here is only positive clockwise. And when you want to represent negative, you will be putting over here. Okay, so this is on how you represent. And this is a positive clockwise. This starting is 0, and this will be a T1, T2, and so on. Basically, T capital letter will be this period, and then this T small letter 1 will be at here, this T2 small letter, and so on. This one is T0. But sometimes your different lecture might be also represent different things, but you need to know this is represent where, and one is where, two where, and so on. So this is all the value. You can just like draw the value first, and then you put it into your truth table. And over here it shows you the output as a C. So you can just like drawing the output. But basically, if you already like learn on the gates, this is not the output, but this is the input altogether. And the output is something that you need to draw by yourself. Otherwise, whatever, maybe the C can be the output, but you are the one will draw, not directly given. Okay, so I guess only that for our class for today. Later on, I'm going to give you exercise, not exercise, which is I give you a video for you to watch, and later on we will discuss in class. So the next coming class is quite interesting because you're going to know and like getting to know on the logic operation, dates, and so on. Maybe before you attend to the class, you can go through the notes, so it's easy for you to answer when I ask and point you to answer the question. So any question? Any
Yes,
question?
madam.
Yeah.
I'm asking if the class will be recorded.
Already recorded. The class is recorded, and normally after end of the class, not directly, because after this I have class also. In the same date, normally I will upload into YouTube and I will put it into your e-learning. Okay.
Okay. Because I entered late and I want to watch the whole thing from the beginning.
Yeah, I get your WhatsApp informing that you just get your vaccines yesterday.
Yeah. Yeah.
Okay. If there is no more question, thank you for all your participants. Where? Next person that will be asked in the class, Ren, Kiyu, and Amir Jamil, because I can see that you did not turn on your webcam. Okay, thank you and bye bye.
Thank you, Doctor.
Bye bye.
Okay.
Thank you.
Thank you, doctor.
Thank you. Bye.
Thank you, Doctor.
Thank you, doctor.
Thank you.